Hi dears, today we can see some results on series. The first result, if summation an converges if and only if for every epsilon greater than 0, there is an integer n such that modulus summation k equal to n to m an, ak less than or equal to epsilon. So this is Cauchy criterion. So Cauchy criterion for the series. Now the second result, if summation an converges, then limit an is equal to 0. So if the series is converges, then you can say that the limit of that sequence is equal to 0. But the converse is not true. You can see this example, summation 1 by n. So if I am taking the sequence of this, so sequence 1 by n whose limit is converges to 0. But summation 1 by n is diverges because we know that p-test is p greater than 1, it is converges, p less than or equal to 1, the series is diverges. So here you can see, yeah, summation 1 divided by n power p. So here p is 1. So this comes under diverges. So the converse is not true. So summation an converges, the limit an equal to 0, the converse is not true. Now the third one, a series of non-negative terms converges if and only if the partial sum form bounded sequence. So series converges if and only if the partial sum form bounded sequence. Then the fourth one, if modulus an less than or equal to cn, and if n greater than or equal to n naught is the fixed integer, and if summation cn converges, then you can say that summation an also converges. The second one, if an greater than or equal to dn greater than or equal to 0, and if summation dn diverges, then you can say that summation dn also diverges. So this is comparison test. Now the fifth one, so this is comparison test. Now the fifth result, if 0 less than or equal to x less than 1, then summation n equal to 0 to infinity x n equal to 1 divided by 1 minus x, geometric series. But if x greater than or equal to 1, the series is diverges. So if we put x is equal to 1 in the series, this become 1 plus 1 plus 1 plus etc. So this series summation 1 is the divergent one. Now the sixth one, summation 1 divided by n for p converges for p greater than 1 and diverges for p less than or equal to 1. So this is p-test. Then seventh one, if p greater than 1, summation 2 to infinity 1 divided by n into log n the whole for p converges. If it is less than or equal to 1, the series diverges. Now the eighth one, a root test. So a sequence, summation of a sequence is given. So for finding the root test, put alpha equal to limit n tends to infinity supremum of nth root of modulus an. And if we get the result alpha is less than 1, then we can conclude that summation an converges. If alpha greater than 1, summation an diverges. And if alpha equal to 1, the test gives no information. Similarly, we can see the ratio test. If we need to find whether the series is convergence or divergence. So for that, put limit n tends to infinity supremum of modulus an plus 1 divided by an. If that value is less than 1, then it is converges. And this value greater than or equal to 1, then we can conclude that is diverges. Then the 10th one, this is the comparison between the ratio test and the root test. If you take the greatest lower bound, then you can see that the ratio test and the root test comparison, that is less than or equal to. And if you take the least upper bound, then you can show that a root test and the ratio test is the widest while taking the supremum. Now the next result, 11th one, given the power series summation cn is at power n. So for that, whether the series converges or diverges, we can take alpha is equal to limit n tends to infinity supremum of nth root of modulus cn. So that is a root test. So R is equal to 1 divided by alpha. If alpha is equal to 0, you will get R is equal to infinity. Similarly, alpha is equal to infinity plus infinity, we will get R equal to 0. So if modulus Z less than R, the radius of convergence, then you can say the series is converges, and greater than R, it is diverges. Now the 12th one, suppose an is equal to summation k equal to 0 to n ak, that is partial sum. So if partial sum form a bounded sequence, if the partial sum form bounded sequence and p naught, p1, etc. value is greater than or equal to increasing sequence, so here bk, yes bk, increasing sequence, and limit of that bn is equal to 0, then directly you can say that summation an into bn converges. an into bn converges. Then 13th one, suppose modulus C1 greater than or equal to C2 greater than or equal to etc. That is alternating series. Alternating series. Then C2m minus 1 greater than or equal to 0, C2m less than or equal to 0 is the second condition. And the third condition, limit of Cn equal to 0, then directly you can say that summation Cn is converges. So this is Leibniz theorem. So Leibniz theorem used to is used to find from the alternating series. Now 14th one, suppose the radius of convergence is 1, and the next condition, increasing sequence like C0, C1 greater than etc. and limit Cn is equal to 0. If this three conditions satisfied, then you can say summation of that series converges at every point of the circle, that is modulus Z equal to 1, but except that Z is equal to 1. Now the 15th one, summation An converges absolutely, then summation An converges. So converges absolutely means if summation An converges absolutely means the condition if summation modulus An is converges. If it's so, then we can say converges absolutely. So here summation An converges absolutely, then directly you can say that summation An is converges. But the converse is not true. So you can see an example here, summation minus 1 the whole power n divided by n. Okay, according to the alternating Leibniz theorem, we can say the series is converges. But if we take, that is summation an converges. But if you take the modulus minus of the whole power n divided by n is summation modulus of the negative value, that become positive divided by n. This is diverges according to the p test. So p test we have p greater than 1, it is converges. P less than or equal to 1, it is divergent. So here it is n power 1. So it is comes under divergent. So summation of modulus an diverges. So the condition failed, so it is not absolutely. So the condition fails, so that we can say that the converse is not true. Then the 16th one, summation an and summation bn, and the cn you can write the product of two series, that is ak bn minus k. So summation cn is called the product of two given series. This is called the Cauchy product of two series. Similarly, we have another one result, that is Abel's theorem. Which says that summation an, summation bn, summation cn converges to the limit a, b, c respectively, and also the condition, that is Cauchy product Cn is equal to a naught, this one. Summation Cn is equal to a naught Pn plus a1 Pn minus 1 etc. plus a and b naught. Then you can write the limit as c is equal to ab. Thank you.